So far, we have discussed the following gas laws. We have the Boyle's law, the Charles law, Gay-Lussac's, and then the Avogadro's law. Again, we can combine the Boyle's law, Charles, and then the Gay-Lussac's into one equation. That is the combined gas law. This time, let's combine all of these laws into one equation. That is the ideal gas law. So this one describes the relationship of volume, pressure, temperature, and the number of moles. So in this case, we just have added the number of moles in the equation. Again, for the Boyle's law, that is this equation, Charles, Gay-Lussac, and then the Avogadro's law. Again, the ideal gas law is the combination of all of these ideas. So we have pressure times volume is equal to the number of moles times our constant times the temperature in Kelvin. So here we use the letter R to represent our constant. Again, on some case that's K, but on this case we are using the letter R. This one is our ideal gas constant. It's equal to 0.0821 atmosphere liters over mole Kelvin. So let's use this one in answering this word problem. How many moles of an ideal gas are there if the volume of the gas is 146 liters at 14 degrees Celsius and a pressure of 3.45 atmospheres? So let's put here our given first, our pressure, volume, our number of moles, and our temperature. Our pressure here is equal to 3.45 atmospheres. This one is our volume, 146 liters. This one is our temperature, and again here the temperature must be its absolute temperature. That is pag Kelvin we need to, or pag Celsius rather, pag Celsius we need to convert this one. Let me fix this one first. We have here 14 plus 273.15, so we have 287.15. 287.15. Let me just check that. Okay, so here we're looking for the number of moles. So let's use the equation. We have PV is equal to nRT. Our pressure is equal to 3.45 atmospheres times our volume is equal to 146 liters. It's equal to our n. We're looking for the n. Then times the r. Our r is constant. This is always equal to 0.0821 atmosphere, then liters over mole Kelvin times our temperature is equal to 287.15 Kelvin. Again, we're looking for the n here. So what should we do here? Divide both sides by this number is over here. So let's divide this one by 0.0821 atmosphere liters over mole Kelvin times 287.15 Kelvin. The same thing on the other side. We have 0.0821 atmosphere liter over mole Kelvin times 287.15 Kelvin. We can cancel this. What's left is n. Then we're going to solve this one. We have 3.45 times 146 over 0.0821 times 287.15. So we have this one, 3.45 times 146. We have 503.7, 503.7 over, both we have 0.0821 times 287.15. We have this number, 23.56, 23.56, 23.56. And from this, 503.7 divided by 23.56. We have this number. We have here 2 sig figs. 2 sig figs, we have 21. 21. Then for the unit, we can cancel ATM, liters, liters. then Kelvin, and also Kelvin. What's left is the number of moles. So we have 21 moles. Next, let's answer this one. At what temperature will 0.654 moles of neon gas occupy 12.30 liters at 1.95 atmosphere? So here we have pressure, volume, our number of moles, and our temperature. Again, our R, our constant, is this number. Our pressure is equal to 1.95 atmosphere. Our volume is equal to 12.30 liters. 12.30 liters. Our number of moles is equal to 0.654 moles. So we're looking for our temperature. PV is equal to nRT. Our pressure is 1.95 atmosphere times volume 12.30 liters is equal to, our number of moles is equal to 0.654 moles times our R, we have 0.821, sorry, 0.0821 atmosphere times liters over mole times Kelvin times our temperature. Again, we're looking for the temperature, so divide both sides by these numbers over here. We have 0.654 moles, 0.00821 atm, liters, moles, then Kelvin, 0.654 moles times 0.0821 atmosphere, then liters over mole Kelvin. Cancel this, then cancel this. What's left is here T. Let's put this one on the left side. Then here 1.95 times 12.30. 1.95, 1.95, 1.95 times rather 12.30. So we have 23.95, 23.95 over we have 0.654, 0.654 times 0.0821. We have 0.5369, 0.05369, 0.5369, 23.985 divided by 0.050369. 23.985 divided by this number. We have this number over here. And then here we have 3 sig figs. So let's round this one to 3 sig figs. We have 447. 447. And then for the units, ATM, liters. We can cancel moles. What's left is the Kelvin. And again, don't forget to box your final answer.